Okay, looks like we're live. You might remember the other day, yesterday, I had a bug that I could not solve. And so I ended the stream without solving it. I then went to my colleague, Dr. Malika Serlanchi, in the Department of Biomedical Informatics. I showed her the optimization problem, and I told her it's the weirdest thing. It doesn't work. But if I then multiply sigma by 10,000 or 100,000, it does. She said, sounds to me like you're missing a square root. That's all the clues she had. And wouldn't you know, I was missing a square root. And so let's solve that. So as a reminder, let's see if, there. How did this compile? How did that compile? Look at square root GDC. Okay, why am I saying that? Because this is the square root, or rather, this is the square root of GDC, but I'm calculating GDC here. If I put that in, I don't need this. Let's take out this times 1 times 10 to the 5. Hopefully this fixes it. That's the zero field reconstruction. Now we're doing compressed sensing. Ah! That wasn't the bug. How is that possible? I fix a major issue and it still doesn't solve it? Oh no. I thought that was going to solve it. Like, why am I even doing it this way? Okay. Oh, what about the procs? We're back to not having it work. Well, that was a short stream. Goodness gracious. Still broken. Wait, do we also need a square root here? And if that's the case, do we just need no square roots? And is that what I was thinking? So there never was a bug? Oh, goodness. This is algebra, like high school algebra, and I am struggling. boy, oh boy, oh boy. Yeah. Never needed the square root. You know, the ball that we're projecting onto is norm of x minus b less than or equal to this divided by num LB is less than or equal to noise bound, right? Times noise bound. So why is there a square root here? Oh, this should have been noise bounds. Wait, noise bound, right? Oh, because this is squared. Okay. It's that times noise bound, which is less than or equal to square root of noise bound, not noise bound, but NB. NB. And that's what that is. Minus B plus B. Well, I'm just going to be sitting here struggling a little while. And then we'll see. What if I multiply this by 1 times 10 to the 4th? Is the answer still great? No, the answer is terrible. What about 1 times 10 to the 6? Is the answer basically 0? That looks pretty good. Yeah, it looks significantly better than the 0 field. That looks great. That looks great. Okay, so 1 times 10 to the 6th works just fine. I don't know about 1 times 10 to the 7th. Let's get rid of this before I forget that I have it in there and think I fixed whatever I fix, whatever I change. For whatever reason, my Twitch stream stopped streaming randomly on my phone. You know, let's just step through this code. Okay. We're going to start out by saying, if compressed sensing is true, else 489. I think we always have to use PDHD with compressed sensing, the way that we're doing compressed sensing. Okay. Prox F is empty and prox G is not. Let's see what F is. Empty. And G? So where does proxaf get called? There. Anywhere else? I don't know why MATLAB does that. Okay, nope. We could put here that if x is zeros, we just skip over apply a. Oh no, because we need to know the size. That's what we want, is just to know the size of. Where's the first time that apply a gets called? There. So we just called the objective value is infinity, starting with zeros. Huh. Concat psi. These are going to be zeros. So I think this here is not going to be infinity. It's zero. Right, because the wavelet transform of 0 is 0, and then the L1 norm of the 0 vector is 0. So clearly this is the one that is infinity. Right. Indicator function. This is going to be the norm of b squared, or 0.5 times the norm of b squared. Recognize function of variable b. Where am I? Which is 32. This bound is 3 times 10 to the negative 6. NB is what? Very large number, 1 times 10 to the 5. Noise bound is 4 times 10 to the minus 11. Okay. These are noise values. Looks like noise to me. Looks like it shades down at the top, actually. What is the standard deviation of the noise? 6 times 10 to the negative 6. So, okay, and what's the variance of that? Something times 10 to the negative 3? Yeah. Why is the standard deviation of noise values real? Of complex noise values. Noise standard is equal to noise variance is equal to noise, variance of noise values. The interesting point is that that is like 1 times 10 to the 5. What? I see. Nope, they're about the same. This is what I expected. I thought we were estimating. I thought that this was an estimate for the noise variance. So let's call it noise variance instead. I guess we can do it like that, can't we? It's cleaner to do it this way because it makes it more clear what the constraint is in the optimization problem. Nevertheless, noise variance should be 4 times 10 to the negative 11. That's about right. That is right. I think the difference is because they used a -1 rather than dividing by the number of elements of the noise values. Divided by that -1. Nope. I don't know. So now we're going to call this noise var. Noise var. Okay. Now let's change it everywhere in here. This is the variance of the noise for our estimate x. If our estimate x was true, that would be the variance of the noise, and we need that to be less than or equal to the noise variance. That's actually very clear. Okay. Is that what we're doing? Where is GDC? What is apply A? What is ADC? Where is ADC created? Here. Apply A. Concatenate psi and MFS. Psi, MFS. So apply ADC is MFS. S might have P in it as well. No, it shouldn't because I didn't supply support, so it doesn't. Okay. MFS. Check adjoint. I don't want to check adjoint. The only thing I'm left with is stepping through PDHG and seeing how it goes. Let's see if I can just find a bug somewhere. Okay, good news is I found a bug. Bad news is it's a totally irrelevant bug that we weren't facing before. Exposition 1 is invalid. Oh. Okay. Oh. Another bug, found and fixed. Look at us go. We're just solving bugs left and right here now. I need to find a variable G. Huh? Wait. Okay. Okay. And with that, we're actually doing the PDHG iterations. X bar is zeros. Z is zeros. How does it know the size of z? Oh, it's just actually 0. That's interesting. Y, where does y get used first? Here. So if y were 0, we'd know this was 0. We could just put an if statement right there that would run in every iteration, but then we wouldn't need to call this, which is probably a whole bunch of operations. Apply a x bar. Okay. The conjugate of the proximal operator is in minus sigma, which is that value, times f in over sigma, the parameter 1 over sigma. We're going to do the prox of GCS, which is prox of L1 complex. Looked at this the other day. By the other day, I mean yesterday. Now we're going to do the projection onto the ball. B is not 0, N is zeros. If this were 0, we'd want to project onto B. So let's say A is just the identity matrix. N minus X plus B minus okay, so another projection of the L2 norm of the indicator function for the L2 norm is projection onto a ball at the location 0. So prox of f is equal to n minus. We definitely don't have that. Oh, n minus, this is I, so n minus n, that goes away. Minus b plus the proximal operator of ax plus b. Okay. So we were projecting onto the wrong spot. Another major bug fixed and nothing changes. So this projects onto B, onto a ball centered at B. This shouldn't be tough. It's definitely minus B. N minus x is 0, minus B, plus the proximal operator of n plus B. Does that make sense? Let's say n is out at some crazy number. Let's say n is at B, so then we want the result to be B, right? See, that's why it doesn't make sense to me. If n is at B, we don't want anything to change. Is this wrong? Either way, it's crazy that I could change this however I want. This plus and minus doesn't seem to affect anything. Prox operator. All right, g of ax plus b. If a is 1, you've got prox of x plus b minus b. X plus b minus b. That will break your head. So if n is minus b, this becomes 0. The projection changes nothing. Out comes 0, and then we subtract b. Oh, because here it's ax plus b, and we have a minus b there. Okay, so this should be minus and plus. Now, if n is b, this is 0. Projects onto 0, then we add b, and that's correct. And there's still a bug, because, of course, there's a bug. So going back to this, yeah, terrible result. You know, Fista, I can sort of pretend that I understand what's happening. But PDHG is just like a proximal operator with a conjugate proximal operator. Proximal operator to the conjugate. No, sorry, conjugate proximal operator. Conjugate proximal operator? Proximal operator to the conjugate. That is difficult to wrap my head around. Huh. What is this proximal conjugate operator? What is prox F? It's prox G. Prox GCS GDC indicator. Okay, I have a question. This is GDC. Okay, so what is the prox of this? We know that 0.5 times the norm of x minus b squared needs to be less than or equal to 0.5 times noise var times NB. So let's get rid of the 0.5s. And we know that x minus b less than or equal to square root of noise var times NB. So we need to project onto the ball centered at B of this. I keep doing that over and over again. So you can't stop there. What is prox G? Prox GCS, prox GDC indicator. And these are column vectors, which is another thing I keep confusing myself with. I don't see an issue with the prox G conj. Theta, I think, is 1. Yeah, that's what it is. What am I using that for? Oh, I see. If it reveals all 0 twice in a row, then it's just going to keep revealing all 0. So there's nothing more to do about that. And that's what I'm doing there. I guess the output is X. We're checking to see if X bar is 0 twice in a row. Okay, Fx is equal to 0. This is just to calculate the objective value, which of course is going to be infinity, because why on earth wouldn't it be? Let's do apply A. Apply A. Okay, see how well that worked? GCS, take the norm of the input, GDC indicator. What would it take to make that not infinity? I mean, to make this indicator not infinity. The bound is so small. Oh! Wait. I thought maybe I needed like a divide NB here. But now I'm seeing that there's a multiply NB here. This is times 10 to the negative 11. This is with normalized data, right? This just seems impossible. This is normalized data. The max of absolute K data is 1. How is the noise so small? It's not noise, it's variance of the noise. So what's the standard deviation? Times 10 to the negative 6. Variance is times 10 to the negative 11. That's like very close to numerical precision. Certainly it's numerical precision for floats, beyond numerical precision for floats. So the square root, the standard deviation of the noise is 6 times 10 to the negative 6. This is a real part of the reconstructed image. If I come in here, that value is something times 10 to the negative 4. I see. So it's only like 100 less than the largest values. Okay. These are all times 10 to the negative 6. So I ask again, what would it take for this indicator function to be 0? X would have to be close to B. I can do that. I'm going to do that just for testing. I can do that by solving the LSQR. Okay. That's the LSQR result with this. So that tells me compressed sensing is doing nothing. It's just satisfying the data constraint, and then the compressed sensing isn't given an opportunity to do anything, which is what we found before, because it's what we found before because we knew that if we increased the threshold on the data constraint, then it got a better image. And so that indicates that the minimizing the L1 norm of the wavelet transform of the image is not changing much. Okay. I'm doing this in the wrong spot. Okay. The thing is that like PDHD is working. I'm not learning anything by stepping through it. Pretty bloody tough. Okay, so I believe the optimization is doing what I asked it to do. And the issue is So I can't help but believe that the issue's with the projection. And I think the projection is working, right? Where's the projection? Okay. Create the functions for the optimization algorithms. Where's the proximal operator of this? Project onto a ball. That seems pretty big. Times 10 to the 3? I'm going to use this here. So this feels like it's doing what it's supposed to. Was I wrong? Is it just the soft thresholding? I wonder if that's it. I wonder if that's it. Where's the proximal operator of GCS? I say, like I solved it, but actually I'm just really hopeful until I realize this probably isn't right. So for an L1 norm, the proximal operator of the scaled norm is the input minus the scaling times the projection onto the dual ball of x over the scaling. For the L1 norm, I wonder why I call that L1 complex and that L2. This is the pseudocode from the document I've got. Absolute minus max of absolute. So prox L1. Okay. This is just for real values, like a complex number doesn't have a sign. But I think this is wrong. See, this is this is closer. Just need to implement soft thresh for complex numbers. All I need to do is squeeze their vectors down by the amount of thresh. Minus b. So if x is b, you don't want it to do anything. Okay. think that's right. Still changes nothing. Okay, we're going to do the warm start thing again. I want to see what the soft thresholding does. Okay. Times mag out? I don't think so. This is mag out minus. C minus. Oh. No, 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 no. This is only true if n is positive. Which is why it's sine in mag in. Okay. The equivalent here would be to multiply here by the phase of n. That's why I did the multiplication. I remember having this a few days ago. And I changed it for some reason I can't remember. This is promising. Okay, so it looks like there's a bug in how we call Debouché. The reason that's relevant is because it looks like we're calling Debouché. Wait, I'm a little confused. What? What just happened? What? 101. We've been here before. We called that before. Why is that failing now? I forgot to reshape. Yeah, that wasn't, nope, just a silly mistake in this debugging stuff. Wait, I'm back here. Okay. Arrays have incompatible dimensions. Not if scalar. Oh boy. Okay, if this is real in do I need all those if statements? If it's real, out is equal to sign in max mag in minus thresh 0. This does not matter if thresh is a. Okay. Now, it also doesn't matter if thresh is a scalar or a vector here. Okay. I don't think this is going to work because I mean, you never know. I didn't think it was going to work because we haven't changed when soft thresholding applies. See, this is totally wrong. Because in has its own magnitude. So when we multiply it times mag out, out. Oh, mag in greater than thresh. Okay, so we either have to do this, put mag in greater than thresh everywhere, or we have to do this. This result of this division is a unit vector of n. Okay, so that gets rid of that. They're equivalent. It doesn't matter. Okay, now these codes do the same thing, and I think they're right. This one has the minus b plus b thing. Clearly struggling here, people. Okay, now I'm going to go through PDHG, and I just want to see what happens when we do the soft thresholding. So X bar here, ooh, why not make X bar X? Oh, X bar is X, Z is 0, so Z temp is now psi times X bar It's 256 times 256, like 65536. Okay. Wave split is not a recognized parameter. Wave, can I just, is there a usage? Yes, I did mean that. Great. Wave split sure looks like a recognized parameter to me. Wave spit. It's probably not right, is it? Wave shows complex. Input to wave shows complex. Okay. Okay. This is indeed the wavelet transform scaled. Now let's do the proxcon. So we're going to take in minus the scaling times input divided by the scale with parameter 1 over sigma. What is 1 over sigma? 258. prox GCS, prox L1 complex. Stats in, these are like down at 1 times 10 negative 3, and T is 258. And I think that's a problem. Do you guys think that's a problem? Because I think that's a problem. No wonder the L1 norm isn't doing anything. Okay. PDHG. We have the proximal of sigma G conjugate. Here we're doing F plus G. Okay, so we start out with the prox of sigma G. Well, we start at Z plus sigma A X bar. Z plus sigma A X bar. Okay. Then we do the prox of sigma G conjugate. Prox of sigma G conjugate. What is sigma? Sigma is, of course, the step size. It's one of the step sizes. Sigma tau is 1 over the norm of A squared. What if I set sigma to like 1 times 10 to the negative 5 or something? The issue is, like, the whole point, this is why we do PDHG with line search, so we don't have to worry about sigma. What is sigma for iteration like 10 with line search? Tau is 4 times 10 to the negative 3. So what is sigma? Let's find out. Wait, what? Where is sigma? There is no sigma here. It's just tau. We got beta tau. Beta tau is 5 times 10 to the negative 3. So 1 over that is 200 for data that's like very small. Okay. What if I set tau equal to some giant number? Does it go back? Yeah, it becomes tiny. So this is tiny. So when we go into the prox G conjugate, this is going to be large, 162. Oh, but we are boosting up the inputs. Okay. So this is like 0 to 1.5. And the threshold is 162. Is this correct? Some proximal operator theorems, some conjugate function theorems. Okay, so prox conjugate of sigma f. So I'm scaling f. Here, f is just the L1 norm. N minus sigma times prox scale by sigma inverse n divided by sigma. So at least replicated what's written here. If lambda is equal to sigma inverse, and this is sigma, how do we get here? Can we get this from this? Let y equal x over lambda. Let y equal x over lambda. Okay? So then here, and let sigma equal lambda inverse. So then this becomes, this would be sigma inverse sigma f star y. And then x would become sigma y Is that the issue? I need to pause streaming for a minute. All right, I'm back. And I've got an iPad. I'm going to see if we can figure this out. Did I get that prox conj function incorrect? I'm not going to show this. Just going to see if we can figure this out. Okay. We've got x is equal to prox lambda f of x plus lambda prox lambda inverse f conjugate x over lambda. Let y equal x over lambda and sigma equal 1 over lambda. So then y is equal to x sigma. So we've got y. Now going to the second line, we're going to replace x in the first line, that highlighted x, with y over sigma. Prox lambda f becomes prox sigma inverse f. X again gets y over sigma in it. Plus 1 over sigma times prox sigma f star of y. Multiply everything by sigma, we get y is equal to sigma prox sigma inverse f y over sigma plus prox sigma f star of y. So prox sigma f star of y is equal to y minus sigma prox sigma inverse f y over sigma. Oh, wait. And so is that what we have or not? Out is equal to n minus sigma times prox of n over sigma with a scaling factor of 1 over sigma. That is what we have. Okay, we're just going to keep checking stuff. No, we're not. I'm clearly stuck. I don't know how to solve it. So maybe we'll try again tomorrow. See everyone later.